In this lecture, we will learn how to derive equation of magnetic field due to curved wire by using Biot Savart law. This figure shows an arc-shaped wire with central angle phi. Each length element ds along path AC is at the same distance r from O, and the current in each contributes a field element dB directed into the page at O. You can easily find direction by using right hand rule. At every point on AC, the direction of ds is perpendicular to r vector. This you can see easily that direction of ds is perpendicular. Thus, theta equals 90 degree. We concluded from figure that theta equals 90 degree, and the Biot Savart law, which is dB equals mu naught I upon 4 pi ds sin theta upon r square. Now we put theta equals 90 degree and our equation becomes dB equals mu naught I upon 4 pi ds sin 90 degree upon r square. We know that sin 90 equals 1. Thus our equation becomes dB equals mu naught I upon 4 pi ds upon r square. Now we integrate ds. dB equals mu naught I upon 4 pi r square integral ds. The integral of ds is s. Thus, b equals mu naught I upon 4 pi r square s. From figure, we note that arc angle phi equals s upon r, and thus s equals r phi. We put s equals r phi in our equation. B equals mu naught I upon 4 pi r square into r phi. This r cancels this r and our equation becomes B equals mu naught I upon 4 pi r into phi. This is our final equation for magnetic field due to curved wire. From the onset, we considered arc-shaped wire. However, we can modify this final equation for a circular wire group by replacing phi with 2 pi, because a circular wire has circumference 2 pi, that is 360 degree. Therefore, for circular wire loop, phi equals 2 pi. Therefore, we are modifying this equation to find magnetic field at center of circular wire loop. So our equation becomes B equals mu naught I upon 4 pi r into 2 pi. This pi cancels this pi, and 2 1s are 2, 2 2s are 4. Our final equation is mu naught I upon 2R. This equation can be used to find magnetic field at center of circular wire loop, and this equation is used to find magnetic field due to curved wire.